Hi everyone. Thank you for joining for securing IoT device and applying machine learning with AWS IoT. Super excited to have you guys over here with us. My name is Syed Ahmed Rehan. I'm a senior IoT specialist solution architect based out of London, covering EMEA region. I work with customers ranging from startup to enterprises, helping them adopt AWS IoT and scale with AWS IoT. And today we joined with Jay Singham, who is a CTO of Era Home Security. So let's begin. So in this session, you will learn patterns for automating connecting devices and mitigating those security risks which you find by automating those patterns. You will also learn how AWS is making and simplifying the process of using machine learning and transforming the products into more secure, intelligent things. And then finally, we will look at Era, our customers, how they have actually used AWS IoT and AWS IoT Device Defender ML Detect feature to in their real life use case. So we will go through a couple of reference architecture diagrams where we look at telemetry data, where customers were actually doing before machine learning, how they were using machine learning using AWS ML Pro services we provide, and then with how easy we have made it for you using AWS IoT Device Defender ML feature to consume machine learning without doing the heavy lifting. And finally, we will look at Era Home Security use case, how they have built a product using AWS IoT and ML Detect feature. And then finally, we'll close with a conclusion. So let's look at telemetry before machine learning. Here you can see customers generally who don't have the capability of machine learning and data scientists usually will say, okay, well, we will use the data we have coming in from the telemetrics from IoT Core, push into S3, and we will look into that later on. Because it does require a lot of machine learning algorithms knowledge for you to build a machine learning model on top of that. This is where they will say, okay, well, we will just use the standard services provided by Device Defender and device management. So from the Device Defender side, you can use the rule base where you do need to have a prior behavioral knowledge of the devices to create the behavioral patterns and get notified if there's any breach or anomaly, and use the log metrics in conjunction from CloudWatch to see exactly what has happened and take actions by sending the data downwards using the device shadow. Now, let's look at second case where customers were actually using defending devices using Amazon machine learning services, which we provide. This is where they will use the telemetry data coming into AWS IoT Core, and they will basically push it into IoT Analytics and get it cleaned up, make it ready for data store, and get it ready for data set to be consumed by Amazon SageMaker, and then create a machine learning model, creating output of that, put into S3. And in conjunction with that, they will use the data coming in from IoT Core shadows. They will use the data coming in from device management. They will use the data coming in from Device Defender, understand the anomaly and take actions on those anomaly. Then make a call to Lambda to understand, okay, what was the machine learning pattern of those devices we had in the past? Should we actually be doing that? And then effectively call IoT events to say, okay, let's trigger this mitigation action to make sure that this anomaly behavior is correct and whatnot. So let's look at the third case where we have a huge ask from our customer asking us that how can AWS make machine learning and IoT easier for them so they don't have to do the heavy lifting, and then they can use their highly valuable resources to enrich and improve the customer experience of the product sets. So here we can see with a couple of clicks, we can enable ML Detect feature and create a security profile specific to your things. This machine learning model works in the background for you, understand the data coming into Device Defender. It basically can take actions based on the mitigation action, and then the violation of the devices which creates, you can basically send notifications to the user in multiple forms. You can actually send it to Alexa as it's part of information to the user to say there has been somebody's trying to break into your door, or you could basically invoke a call using Amazon Connect or text message to say that please look at your cameras, there might be some issue here. We think that somebody's trying to break into your door, or we can send an email through using SNS, or send a notification through your mobile app. So let's look at how easy it is to just enable the ML Detect feature. Effectively, you don't need any prior behavioral knowledge of the device. Um, and the machine learning algorithm applied autonomously once you have enabled the ML security profile on your things. So, and the data is adjusted every 24 hours based on your device behavior. What you could also do is come back and tweak your ML metrics and say, I would want to basically have a high confidence level of the ML model or low confidence level of the ML model and so on. And you will be able to build the model once it's active every 24 hours to take those actions. And you can also create a couple of mitigation actions which we provide. For example, if a device is violating a behavior, you could effectively move that device into quarantine group and take actions based on that. So let's look at, by going through a walkthrough, how easy it is for us to enable ML detect feature.
Let's look at how easily we can enable AWS IoT Device Defender ML Detect feature. So from AWS Management Console, let's go into AWS IoT Core. And on the left-hand side, we have a section for Device Defender. And under Device Defender, we have Detect. And under Detect, we have Security Profile. We have two types of security profile. One is ML-based security profile, and other one is rule-based security profile. Let's quickly look at rule-based security profile. In the rule-based security profile, we have given you the metric options for cloud set metrics, such as authorization failures, connection attempt, disconnects, message size, and source IP. Similarly, the device side metrics, such as bytes in, bytes out, amount of TCP connections open, TCP ports open, and same with the UDP. There are other data points you can basically touch here, such as defining specific duration, where you can basically say, okay, if the device enters certain data points to raise the alarm and when to basically clear the alarm. You can set it up to a statical threshold by defining to all your devices or giving it to a specific absolute value on the sections. Looking at this, let's look at into creating ML detect security profile. So let's create the create security profile button and select ML anomaly detect profile. And in here, we're presented with multiple options. So here, target being all your things, or you can assign it to specific groups. So I'm going to select all things here, and I'm going to give a profile name and description. And I'm also going to untick this box so I can dive deep a little bit onto the metric configurations. A point to note here, once the profile has been created, you're always able to come back and modify settings here in terms of the data points to trigger alarms, to data points to clear the alarm. You may basically want to come and tweak this. So anything we basically tweak here modifies and updates the machine learning model and builds it every 24 hours once it's active. So in here, we have authorization failure metric, connection attempts metric. Then we also have notifications to be suppressed and not suppressed. So for authorization failure, I will say not suppressed, connection possibly not suppressed. Then we have a final box. This is the ML detect confidence box, which is predominantly used in the backend algorithm to create the machine learning model for you. So we have multiple options such as high, medium, and low. High basically means low sensitivity in anomalous behavior evaluation and frequently lower number of alerts. Medium effectively is medium sensitivity, and low is high sensitivity in anomalous behavior evaluation and higher number of alerts. So for authorization, I probably will go with low. Connection probably will go with low. Rest of them, I'll keep them default. And let's hit next. And in here, this is the review metrics behavior configuration screen. Everything looks as it is, what we basically selected, and I'm happy with it. So let's go ahead next. Before we go ahead and hit next, let me untick this box because I want to modify the SNS topic I want to send this notifications to. So untick the box and let's hit next. And in here, you can create your SNS topic by hitting create, or I had one created earlier. If you had your own created earlier, you can use them. So I would use the one I had earlier. And I will use the role. It's an IAM role, which grants permission for Device Defender to publish on the SNS topic. And let's click create. Okay, so the profile is created. We can basically go and see the training report of the ML model. So if I select this and go into actions and select view ML model training report, I can see that it's pending build. It's attached to all things, the target, and the notifications we can see here, which are not suppressed, on the ones which are suppressed. We can also see here on the bottom left hand side number percentage of training data is required. So generally we say 14 days for the training data, and on the right hand side is specifically applied to the metrics. So let me go back to security profile and look at the security profile I created earlier. So let's select the one I created earlier, and let's quickly look at the model training report on that. And in here you can see it's active and it's 100% has the training data required, and all the metrics has been met as well. Now let's go back into mitigation section. In mitigation section, we can look at creating actions when the device actually has violated, and we can take mitigation actions on those violations. So let's hit create. And in here, what I want is I want any devices which are violating, and I want them to move into a quarantine group. So I had created a quarantine group earlier. So I will basically name this reinvent 2020. And I will use the execution rule similarly as demo one and attach this to it. And I will attach this to quarantine group, which I had selected earlier. And let's just save that. Now let's go into the alarm section. And within alarm sections, we can see active violation alarms. So I have a couple of devices which are actively violating. We can also go into history section and look at the previous alarm of devices which had cleared alarms, and they were attached to ML detect profile because that's the profile is active. And we can also see actions in terms of devices cleared actions and how many are in alarm. So let me just quickly go back into active section, and within active section, let me pick up DDML1 thing name, and let's look at the violation is doing. So on the bottom left section, we have violations. So we can see it had created 187 messages in a short period of time. So let me look at these violations. So if I come in here, let's zoom in further. We can see here that it generally has picked up, and there's a lot of messages being sent. Generally, we're looking at around 38 messages being sent over the course of the period, where I'm seeing here 300, I'm also seeing here 300, I'm also seeing here 300, which is why it's created violations. We can also look at further actions here in terms of messages received from the device side as well. So let's have a look at that as well. And you can see here by zooming in, this definitely has picked up. So the device has become very chatty. 9,000 messages received. So it's definitely violating it. So let's look at how we basically can mitigate this action and move the device into quarantine section. So let's come into start mitigation action section and mitigate the devices which are actually violating the predefined behavior. And we will select action to reinvent 2020, which means move the devices into quarantine group. And let's hit confirm. And in few seconds, it will confirm that the progress has been completed. You can see that it's completed. So there we have it. How easy it is to use the machine learning capability of AWS IoT Device Defender, which is doing all the heavy lifting for you within few clicks without having the background knowledge of machine learning or data science.
So with that, I'm going to hand it over to Jay from Era, and let's see how they have been using AWS IoT and AWS IoT Device Defender ML Detect feature in real life products.
Thank you, Syed. I'm Jay Jayasingham, CTO at Era Home Security. Let me tell you guys a little bit about Era Home Security. Era has been at the heart of British lockmaking for more than 180 years. If you're watching this from England, check your pocket. Most probably you will have one of these, a key, Era key. Era is part of a much bigger organization called Timon PLC. Timon operates in multiple countries and focus around locks and door and window hardware for the construction industry. I want to talk a bit more about our journey on smart home. Now, Era's smart home journey started more than 10 years ago. I'm originally from a company called YCAM Solutions. We are one of the first company to get into smart home. We launched our first camera in 2011. It's a cloud-based camera, cloud-based indoor IP camera, which is the first camera to give free cloud storage. We started using AWS from day one. So we have a legacy with AWS. We've been using it for more than 10 years. We sold the company to Era back in 2019. After selling the company to Era, we started working on some new products. Let me give you some idea around our new products. So we have alarms, we have cameras. All these things can be controlled through a single app. And if the user decided to sign up for a subscription, they can sign up for a different type of subscription that we got. One is called professional monitoring, which will provide you a police guard in the event of a burglary or whatever that happens to your property. What I want to do today is I want to talk about some of the problems that we faced in our legacy platform and the new platform that we built in 2018. Now, being a 10-year-old AWS customer, we have a number of legacy issues. The first thing that I want to talk about is custom RTSP and HTTPS tunnels. Our cameras and the alarms excuse me, sit behind a number of routers, and these routers don't like to let any stream go out. So we ended up building our own tunnels. We had various success rate based on the country. So in UK, we had a high success rate. In Germany, it'll be around 90% success rate. Load balancing used to be a problem as well. We have hundreds of thousands of cameras connected from all over the world, actually more than from 100 countries, and load balancing them used to be a problem. Firmware upgrade is another problem. You push your new firmware to hundreds of thousands of cameras, and then you don't know how many cameras actually successfully upgraded, so how many failed. The final one, which is the most important one maybe for this session, is the SLA that we have with some major companies. Part of Era, we also provide our technology platform and the hardware to a number of consumer electronics and telecos. They are all obviously under their brand name, but we have strong SLAs with them. So part of the SLA, we monitor the uptime, we monitor the performance, and we monitor the security. To do all of this, we built a full ELK stack, and we also created an alerting mechanism that will alert our 24/7 monitoring team when things goes wrong. So this is our legacy architecture. You can see on one side, we have cameras and the alarms. They all send telemetry data or video data, depend on which device we're talking about. And these data come to our load balancers, and the load balancers will reroute the data based on the device to our reverse proxy servers, which are the custom tunnels I talked about. And if it is a camera, we will start recording those videos in our streaming servers, and then the video gets stored in the S3. If it is a telemetry data, then it goes through our API servers and to our DynamoDB. So old architecture, we were only using EC2, S3, RDS. So back in 2018, we decided that we want to go for a new architecture. So we start using AWS IoT Core to replace our tunnels. Then we ended up using more IoT services like IoT events, device defender, device management. So the first thing is when we start using AWS IoT Core, we replace our tunnels. And firmware upgrade become much easier because once we push the firmware, we will be able to see how many firmwares successfully upgraded, so how many failed, 2%, 3%, we will be able to see that. And then finally, this is the part, this is important here, is the SLA part. What we were doing is we were getting all the telemetry data from our cameras and the alarms. And these data is stored in logs. And then we were running a custom built machine learning algorithm that was looking for unusual patterns in this data. And then if it sees anything unusual, that can be frequency of the data, size of the data, it'll alert our customers. So we were forced to maintain this machine learning algorithm, and also we were running it on a number of servers. So this is the part that we want to replace with ML Detect. So we've been running with ML Detect for the last few months, and we have already seen some improvements, how it'll help us moving forward to replace our custom machine learning algorithm, and also to save us some time on maintaining that. So this is the new architecture that we came up with in 2018. Just want to take one example, which is the door lock. So the door lock send telemetry data for a couple of data that I can give you. One is when you are opening up the door, it sends data. If there's a low battery, it sends data. This data comes to IoT core, and from that IoT core, it goes to device defender. Device defender look for unusual patterns, and then SNS and connect, and if there is anything wrong, and it calls our customer. So this is the new architecture. You can see that we do not run any servers anymore. This is very much serverless. We also focused on edge-based with this architecture, where we were running human detection and some other detection algorithms on the camera. So what's next for us? We are going FreeRTOS in all our embedded devices. We want to start using Device Defender and ML Detect heavily to replace our custom algorithms and also to connect our SLA to it. And finally, we want to go totally serverless. So that's the future for us. What I want to do today is I want to do a demo on one of the prototypes that we have built so far. It's a smart lock that works with fingerprint scanners and everything. And we want to show how ML Detect is working behind the scene to alert when an unusual activity happen on the hardware, alerting our monitoring team. This is a smart lock prototype that we're going to use for this demo. There are three ways to open this. First, using Bluetooth. If you're using Bluetooth, you need to have our app. That's the Era Protect app. Second one is using fingerprint. If you're using fingerprint, you need to register the fingerprint first with the smart lock. Third one is using a physical key. What I like to demonstrate today is, I like to demonstrate the use case where when someone is trying to get into your property with a fake fingerprint or their own fingers, you get a call. This is a very useful functionality of the product. Let's say I'm in the office and someone is trying to get in and I get a call, so I can react to that problem. So I have already registered one of my fingers with the smart lock. So when I touch the smart lock, it'll show a green light and it'll allow me to push the handle down. If I use one of my fingers that's not registered, then it'll show a red light and it'll not allow me to push the handle down. So first, let me show you the functionality with the finger that I have already registered. You can see there's a green light and I can push it all the way down. So this will unlock the door. Now I'm going to use a finger that's not registered with the smart lock, and after 3 failed attempts, I would expect a call to come through. So this is a finger that I haven't registered with the smart lock. You can see it's a red. I'll try again, another red. And now I'm going to try the third time. Now after this, I would expect a call to come through, informing me there is the call. Let me pick up the call and I'll put it in. put it in speakerphone.
Your door lock with an unrecognized fingerprint. Launch your ERA Protect app if you would like to check your cameras.
So after the call, what I would do is I will log into my app where I have my door cams and I can check whether there is anyone in front of my property. So that's the demo. So what's happening behind the scene is, as Said said, the smart lock is sending constant messages to IoT core. When ML Defender detects unusual messages, it triggers AWS Connect, and that's how I got the call. Thank you. With that, over to you, Said.
Thank you, Jay. So with that, let's see what AWS IoT can do for you. With the slide deck we have for this presentation, please go through and see how our other customers are enriching their IoT devices using our platform. Also go and have a look at the learning materials we have provided in this slide deck. There are plenty of links for you to get going and get started with AWS IoT and AWS IoT Device Defender ML Detect feature. Thank you very much for joining us. I really appreciate and super excited to have you guys all here with us, and really appreciate if you guys can complete the survey. Thank you and goodbye.